Welcome to this demonstration of the Entangled Photon source, which is a device that we will be using in many of the upcoming experiments in this video series. Its basic components are this box with a pump laser and these two mirrors reflecting the outgoing light into these fiber couplers, which we can then connect to other devices. Let us open the box to see the details of the setup. Here we have the laser source emitting laser light of 405 nanometer wavelength, passing through this collimator, getting reflected by these two mirrors, passing through this aperture and then hitting this half-wave plate. The half-wave plate ensures that the light is diagonally polarized. Afterwards, our beam hits this ytterbium vanadate crystal. Actually, we have two of this kind. This is the other one, and the reason we need them I will come back to later. The central part of this setup is this one. It actually consists of two smaller pieces, namely two BBO crystals aligned perpendicularly and then sandwiched together. Let us recall what happens in a single BBO crystal. We may summarize it as spontaneous parametric Down conversion with type 1 phase matching. When everything is aligned correctly, a vertically polarized pump photon entering the crystal can cause it to emit two horizontally polarized photons of double wavelength. These are then emitted along a concentric cone around the pump beam axis. On the other hand, a horizontally polarized photon will just pass through unaffected. A second BBO crystal, rotated by 90 degrees, can correspondingly emit two vertically polarized photons when it is hit by a horizontally polarized pump photon. Now, since our pump beam is diagonally polarized, these two effects add up to create a superposition state of photon pairs, with one part being vertically polarized and the other horizontally polarized. However, the use of two BBO crystals introduces additional dispersion effects and temporal shifts of the generated photon pairs. This means that in principle, one could detect in which crystal a given photon pair was produced, which could spoil entanglement effects in a given experiment. This is fixed by these two ytterbium vanadate crystals, which selectively delay the propagation of some photon modes. Thus, in the end, we have an entangled photon pair propagating along the displayed cone. Finally, we need to keep in mind that only a tiny part of the pump photons are converted into entangled photon pairs. Hence, we need to block any remaining laser light using this long band filter. Now, to see that this setup is actually really working, let us turn it on. Now this gadget has to start heating up, and then we can set the current. And I will use these glasses for safety. Finally, we have another safety measure, an interlock. Like that. Now we can turn on the laser. And as you can see now, this laser is actually turned on. We do have a working setup and laser light is passing through this device.